I'm going to talk about 39 combination sum. The question is given an array of this distinct integer candidates and a integer target. And return a list of all unique combinations of candidates where the chosen numbers sum to targets. You may return the combinations in any order. So the same numbers may be chosen from the candidates an unlimited numbers of times. So you can repeat and choose the numbers. Two combinations are unique if the frequency of at least one of the chosen number is different. The test case are generated such that the number of the unique combinations that sum up to target is less than 115 combinations for the given input. So how can we solve this problem? So I will say it's use the combination problem, right? It's look like subset. So we have like 2, 3, 6, 7. Kind of like we have the two options. For example, if for the numbers 2. So what's going on is we can the left branch means the not choose. The right part means choose. Then not choose for the next level, it should be the like this. And for the choose part, it can be the 2, like here. And then we keep moving to the next level. And during this process, we also need to know cur sum, right? Current target, whether equal to 0. If equal to 0, which means we find the current here, like for example for here, right? 2, 2, 3 here. So which means in the subtree, it must be have this one. Then we find that the target definitely is equal to 0. Then we add this sub result into our total result and return back, and to go to the another like another thing to find this one. So it's used the backtracking. So I would say the solution is the algorithm, whatever algorithm, is use the backtracking topic. Is use the backtracking. Why is use backtracking is not use the DFS? Because for the DFS, you just to find one of the, if you go down, right, if you are lucky enough, you can find the left tree and you can find the result. Then you can just return back and not worry about the right part. But for the backtracking, which means you have to search all of them. Even you find this one in the left one, you also need to go to the right part to find another problem, because the results, it might be happen in the right tree, right? So that is different between the DFS. So for this one, the process, the sub result is important, so we need to use the backtracking. So let's write the code. So definitely use the backtracking, which means we can analyze the time for here is when we go to the specific level, right, we need to add the result input to our total result. This will be n times. This is time complexity. And also we have the 2 branch. So for the tree, normally is branch level here. So we can treat that the time complexity is the 2 branch. How many level? N level, the worst case, right? And then for the space, we also based on this N level. And then for the result, this one we didn't calculate. So yeah, let's see. Result. And then for the integer, Okay, then we use the backtracking and return the result. Void. List integer. So for the backtracking, we can write here stuff from the 0 and date, target, result. Okay, so for here we have some base case. If the index and if the target equals to 0, or index is equal to the candidate's length, which means we don't have any candidates we can choose, and we can return actually. So we can return, but before we return if the target here, actually we can separate it. We can write this. So if the target is equal to 0, right? So we can add the result at the current subresult and return back. So that is base case. And if not, which means current now the target, we actually can smaller than result. Which means for here is target is larger than 0, we still have the candidate to move to choose, right? So we can gather the current candidates. Candidates index here. So for here we can do something for the next. So we have the not choose. So if not choose, we backtracking, which means we skip current index. Candidate, target, subresult, go to next level. And for choose, which means add curve, and go to the next level. We didn't skip that because it's a repeating one, so we don't do this one, so we still can pick up. But for here, target need minus this one. And then when we return back, we should return to the original. We're backtracking. Integer. Oops, remove the -1. Yep. And for the time complexity, we can see here we need to store here, so this will be O(n) time is for here. And for the branch and level, it means to calculate how many nodes we have. So every node we need to run this one. So this is the time complexity about this. For the space complexity, is based on every time you just go to one, right? Kind of like, which is called stack, and you have to create the space. So the worst case is like here. And for the return here, we didn't do any calculation. If you want to calculation, kind of like you steer here. Yeah, thank you.